11.7 is called the rational zero theorem. So let's write down what that is. If a simple fraction in lowest terms is a zero of the polynomial, then the numerator of the rational zero is a factor of the constant term of the polynomial, and the denominator of the rational zero is a factor of the leading coefficient of the polynomial. So what we're going to be looking at today is two things that we're going to call our p-value and our q-value. Our p-value is going to be the factors of the constant term. So if you think about a polynomial, your constant is the one at the very end without a variable. And q is going to be the factors of the leading coefficient. So we're going to take a look at these two things, and this is going to determine where our possible rational zeros are going to be. So for example, our first one is 3x to the fourth minus 10x squared minus 8x plus 15. So our p-value is going to be the factors of the constant. So our constant is 15. So this is our p-value. So what I want to do is I want to jot down all of my factors of 15. So that would be 1, 3, 5, and 15. But we can also include the negatives. So I'm going to put one big plus or minus sign here to talk about all of the different factors of 15. Now I want to look for my q values. And q values are the multiple factors of the leading coefficient. So this is our q value here, 3. So again, I could use all the positive or negatives here, and all of my factors of 3 are just 1 and 3. So now what I want to do is I want to say, okay, p divided by q is going to give me all of the possible places that our polynomial could have a 0 or a root or an x-intercept on our graph. So if I divide those out in all of the combinations, I'm going to use one big plus or minus sign. I'm going to start here with my 1 first. So 1 divided by 1 is 1. 1 divided by 3 is 1/3. Now I'm going to move on to my 3. 3 divided by 1 is 3. 3 divided by 3 is 1, which I already have listed here, so I'm not going to repeat that. Now I'm going to move on to my 5. 5 divided by 1 is 5. 5 divided by 3 would be 5/3. Now I'll move on to my 15. 15 divided by 1 would be 15. And 15 divided by 3 would be 5, and that's already listed. So what this list is a comprehensive list of all of my possible zeros, meaning that it could only cross if it's going to be rational, okay, at 1, 1/3, 3, 5, 5/3, or 15. And why is this helpful? Because sometimes these polynomials are really tricky, okay, and if you're trying to figure out the factors are only going to come from a rational zero. So how do I know where it's actually going to cross? Well, in that case, we are going to go ahead and we are going to graph it in our calculators to go ahead and see where it actually crosses. So go ahead, pause the video, and graph number 1 in your graphing calculator. Okay, so if you graphed this correctly, you should have gotten a graph that looks like this. So what you can see is it crossed the x-axis twice right here. Okay, it crossed at 1. It crossed at 1, and it crossed somewhere else. I want you to go ahead and find that decimal of where it crossed. Okay. If you did that step correctly, you're going to notice that 1 was one of our zeros, but that the second place across the x-axis was not one of these decimals. So our only rational zero was at 1, 0. So again, the green is all of the possibilities, and the red is where we double-checked by graphing to find exactly where that crossed. All right, so let's try that again here in number 2. X to the 5th plus 2x to the 3rd minus x squared minus 2. My p-values, again, are the factors of the constant term. So that's going to be plus or minus 1 and plus or minus 2. Then I'm going to take a look at my q values, which are the constant of the leading coefficient. So that's just going to be plus or minus 1. So again, your Q comes from your leading coefficient, and your P comes from the value at your constant. So then if I find my factors where I'm going to do P divided by Q and get all of my options, I'm going to have 1 divided by 1, which is 1. Then I'm going to have 2 divided by 1, which is 2. So in this case, I only have the options at plus or minus 1 or 2. So go ahead, graph this one, pause the video while you do, and find where it crosses the x-axis on that graph. Okay, so you should have graphed and seen it look like this. So it should look like this. So if you found that x-intercept, you should have found that that x-intercept crossed at 1, 0. So indeed, our final answer for where it crossed would have been at 1, 0. Okay, so let's try this again. Number 3 is giving you the polynomial 30x to the third minus 31x squared plus 10x minus 1. First thing I want to do is find my p-values. Again, p comes from the factors of the constant term at the end. So in this case, it's just one option. My q values come from my leading coefficient, and this one's going to give us a lot of options. So if we think about all the factors of 30, I'd have 1 and 30. Let's see, 2 and 15. I'd have 3 and 10. And then 5 and 6 as well. That's not a very clean list. So 1, 2, 3, 5, 6, 10, 15, and 30. So my possible zeros are going to go ahead and be all of those plus or minus. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. 1 divided by 5 is 1/5. 1 divided by 6 is 1/6. 1/10, 1/15, and 1/30. Okay, so these are all of the possible factors. I'm sorry, all the possible zeros. And now I'm going to ask you again to graph that on your calculator and find the place in which that crosses the x-axis to double check what we've got here. So as you can see, this is what your graph should have looked like. And I've got 3 intercepts here. I've got 0.5, I've got 1/3, and I've got 0.2. So I have 3 zeros right here. 0.2, which is 1/5, 0.33, which is 1/3, and 0.5. So let's go ahead and jot those down as our 3 zeros. So we had 1/2, 1/3, and 1/5. So then to turn those into the factors, this is something we've done a lot. 1/2 would be 2x minus 1. 1/3 would be 3x minus 1, and 1/5 would be 5x minus 1. So that's how you would turn your possible zeros, check it on your calculator, find out where they actually cross, and then get your factors from here. This should make sense because we found 3 zeros, and it was a cubic function, so that checks off our list as having the correct number. Okay, so let's go ahead and do number 2 here. Again, I want factors of my constant first to be my p. So I've got plus or minus 1, 3, and 9 for factors of 9. Then my factors of q come from my leading coefficient. So that would be plus or minus 1 and 2. All of the possibilities are p divided by q. So I've got 1 divided by 1 is 1. 1 divided by 2 is 1/2. 3 divided by 1 is 3. 3 divided by 2 is 3/2. 9 divided by 1 is 9. And then 9 divided by 2 is 9/2. So those are all of my possibilities. I'm going to have you go ahead and graph that yourself and then come back and check after you have. If you graphed that correctly, you should have found that it crossed at 1/2 and 3 and -3. So it had both a plus and minus 3. So then those factors would become 2x minus 1, x plus 3, and x minus 3. Again, that makes sense because it was a cubic function that we would find 3 zeros. Okay, I'm going to have you try the next one on your own. So pause it, okay, and then come back and check when you have finished it. Okay, so if you did it right, you would have gotten your possible zeros to be at plus or minus 1, 1/7, 2, and 2/7. And then you should have graphed it to check, and you actually would have found that there was none that crossed the x-axis, meaning you have no real rational zeros. So this full explanation would say no real rational zeros, meaning they could be imaginary or complex. Okay, so awesome job. Your homework is going to be 11.7b in your homework packet, so you can go ahead and get started on that.